Dear student, I am Manor Patil. Already we study about the differentiation of class 12 part 2nd, the most important chapter. So already we study about the some basic formulas. In first lecture we complete the some basic formula along with the simple level questions. After that we complete the question based on the multiplication property of derivative. Then we go for the division property of derivative. After that, now this is our next lecture. So in this lecture we have to study about the composite function derivative. It is also called the chain rule. Now very simple questions are there. You have to just remind all the formulas. So the derivative of x raised to n, that is n into x raised to n minus 1. The derivative of a raised to x, that is a raised to x into log of a, and then derivative of e raised to x, that is e raised to x. Most importantly, the derivative of log of x, that is 1 upon x. The derivative of constant, that is 0. The derivative of root x, that is 1 by 2 root x. After that, we remember the all derivatives of trigonometric functions. So 1 by 1. So 1 by 1 we complete that formulas. So derivative of sine, that is cos. Derivative of cos, that is minus sine. After that, derivative of tan, that is sec square x, and derivative of sec x, that is sec x into tan x, and the last one, that is the derivative of cot, that is minus cosec square x, and cosec derivative, that is minus cosec x into cot x. And most importantly, the inverse trigonometric uh, functions derivative. So that is sine inverse x 1 upon root of 1 minus x square, cos inverse x minus 1 upon root of 1 minus x square. After that, the tan inverse x, that is 1 upon 1 plus x square, cot inverse x minus 1 upon 1 plus x square, and then sec inverse x, that is 1 upon x into root of x square minus 1, and last one, that is cosec inverse x derivative is minus 1 upon x into root of x square minus 1. So in such way that you have to remember all the formulas, then we go for the one by one question solving. So let's we start. So this is the first question, very simple. First we have to read that. So y is given, and now here two functions are there, sine and the bracket, that is the angle of sine, that is m into sine inverse x, and now we have to calculate dy by dx. So first step, you know that, so differentiating y with respect to x, we get, so very simple. So first step, always remember differentiating y with respect to x. After that, apply dy by dx on both sides, and this by using the formula, or how we solve, and after that using the formula we get the final answer. So apply the dy by dx on both sides. So that is d by dx equal to d by dx of, that is sine of, into bracket m into sine inverse x. So we know that here, what is the derivative of sine? So derivative of sine is, that is cos having angle as it is, that is m into sine inverse x into, so derivative of that function, now this is called chain rule. So that is m into sine inverse of x. So now here very interesting, m is the constant, we do not take the derivative of constant, write down the outside. So that is m into cos m sine inverse of x, and most importantly, what is the derivative of sine inverse of x? So derivative of sine inverse of x, that is 1 upon under root of 1 minus x square. Now this is the final answer of the given example. So very easy question, so very simple. So now we go for the next one by one. Let's practice. So next example is there. So y is the function of e raised to m into sine inverse x, and then we have to calculate the dy by dx. So steps very similar. First we have to take differentiating with respect to x. After that, applying the d by dx, and then by using the formula we get the answer. So that is differentiating y with respect to x, we get, so that is dy by dx equal to d by dx of e raised to m into sine inverse of x. So know that what is the derivative of e raised to x as this. So derivative of e raised to x, that is m into sine inverse of x. We taking the derivative of complete that exponent. So what is the derivative of m into sine inverse x? So m to constant. So what is the remaining term only? That is sine inverse x. So write down the e raised to x as it is, m into sine inverse of x into, so m is the constant, so we only take the derivative of sine inverse x. And what is the derivative of sine inverse x? 1 upon under root of 1 minus x square. Now this is the final solution of the given example. It's very easy. So let's make practice. Write down the example, take the screenshot. Remember, very easy. First, the basic function, we have to look at that basic function. then taking the derivative of that function. After that, what is remaining into that functions, so that we solve the, again taking the derivative by using the chain rule, and then we make sure that the final answer is there. So we go for the next example. The next example, again very simple. Y is given as a function of log, x is given, but there is a log, and the into the log of x into e raised to x. So very simple, x into e raised to x, both are the function of x and both are in product. So definitely we have to use the product rule, and then we solve dy by dx. So differentiating y with respect to x, we get, so that is dy by dx equal to, so d by dx of log of then x into e raised to x. So very simple. So taking the, what is the rate of log x, that is 1 upon x, so it's completely at the denominator, x into e raised to x. After that, again taking the derivative of x into e raised to x. So now we solve x into e raised to x by using the product rule. So what is the product rule? That is the derivative of product function. How to calculate? Very simple formula, dy by dx equal to u into dv by dx plus v into du by dx. So where u and v, consider the x as the u and e raised to x as the v. So then solving by using the formula. So very easy to calculate. So that is 1 upon x into e raised to x. As it is, apply the formula. So that is x into d by dx of e raised to x. Very simple to remember. Then e raised to x into d by dx of x, bracket complete, we get. So that is again simple. So after that, taking the derivative of e raised to x, that is e raised to x, and plus e raised to x as it is, derivative of x, that is 1, by using the formula x raised to n, that is n into x raised to n minus 1. According to that, we solve the derivative of x raised to 1, that is only 1, and then final dy by dx. But so from here we can observe that clearly by taking the e raised to x common, remaining term in that is x into e raised to x, the bracket present, that is x plus 1. So after that, e raised to x get cancelled. So what is the final answer? So final answer, dy by dx equal to x plus 1 divided by x. So now this is the solution of given example. Important question, many times they ask into the examination, so very easy to solve the example. Just you have to observe that which formula we have to use. Now here we clearly observe that there is a product of two functions, so therefore by using the multiplication property of derivative, and by using the formula, very simple, dy by dx equal to u into dv by dx plus v into dv by dx. According to that, we calculate the question. So just take the screenshot of the given example, very easy. Let's we go for the next example. So the next example is, so now he given y is equal to log to the base 10, and after that, so then into the bracket log of x to the base e. So remember, log 10 is not equal to 1 and log of e is equal to 1. So according to that, so and we calculate dy by dx. So first step is very common. So differentiating y with respect to x. So we get, so apply dy by dx on both sides. So whenever we apply the dy by dx on both sides, very simple step you have to make sure that now here by using the simple formula of logarithmic, log a to the base b, we can write down the log of a divided by log of b. So by using this formula, we apply the formula here. So after we get the simple answer. So log of a, complete term a to the base b, consider the 10 is the b. So if 10 is the b base to the log, so we can write down at the denominator. So therefore we write down now here, that is log of 10, and most importantly 1 upon log 10 is the constant. So we take the only derivative of that function, and the function is log, then log x to the base e, log of e1, remember that. So that is 1 upon log of 10 into, so what is the rate of log? 1 upon x. So that is log of x. Derivative of log of x. So derivative of log x, 1 upon x. So derivative of log x, that is 1 upon log x. And again we take the derivative of log of x to the base e. So but remember that log e having answer is 1. So what is the last answer? So last answer is So the derivative of log of x, that is 1 upon x. So this is the final answer of the given example. So then the final answer is dy by dx is equal to 1 upon x into log 10 into log of x. So in such way that we calculate the given question. So very easy to remember. Make sure that make the notes, write down, remember the formula. Very simple. By using the formula, we calculate it by using the chain rule. It is called composite rule or also chain rule. Take the screenshot. We go for the next. Okay, so next example is very simple. Y equal to under root of sine x and then root x. We find dy by dx. So that is differentiating, again similar step. Y with respect to x we get. So then dy by dx equal to d by dx of under root of sine of root x. Now here, so by using the formula of under root of x, what is the derivative of root x? 1 by 2 root x. So 1 upon 2 times under root of, as it is, that is sine into root x. Again take the derivative of what is the remaining complete term inside the under root, that is sine of under root of x. So again taking the derivative 1 upon 2 under root of sine under root of x as it is. So tell me, what is the derivative of sine of x? Sine derivative, that is cos of x, and then now here sine root x, so derivative becomes cos root x, and again we have to take the derivative of under root of x, and finally we know that what is the derivative of under root x, that is 1 by 2 root x. So in such way that we get the final answer is 1 upon 2 root x. So therefore, so that is dy by dx is equal to cos of under root of x divided by 2 into, sorry, so 2 twos are, what is the, we make the multiplication, 2 twos are, that is 4, 2 into 2, that is 4 times root x, and then remaining term is under root of sine into root x. So now this is the final solution of the given question. Question is very easy. Now we solve the question by using the composite function, and it is also called chain rule. Very easy. We just observe the first basic formula we can use, that is under root of x derivative 1 upon 2 root x. So similarly we use 1 upon 2 root x, and now under root, the sine root x is present instead of x, so we again take the derivative of that, and after that taking the derivative of sine, that is cos, and again taking the derivative of root, that is root of root x derivative, that is 1 by 2 root x. So in such way that we complete the given question. Make sure that notes, write down the notes, and then we go for the next. So next example is again very easy. So what is given? Y is the function of e raised to, and then e raised to power is root of cos x. So find dy by dx. So now here under root is present. So we know that what is the derivative of root x, that is 1 by 2 1 by 2 root x according to that, and next is cos derivative, that is sin x. So differentiating y with respect to x, we get, so apply dy by dx on both sides. So that is d by dx of e raised to under root of cos of x. So what is the derivative of e raised to x? That is as it is. So we write down the as it is, and again take the derivative of that function. What is the function is here? That is root of cos x, and then e raised to cos of x. Again taking the derivative of under root, that is 2 into under root of cos of x, and after that what is remaining? That is final is cos of x, and we know that what is the derivative of cos of x? That is minus sin x. So what is the final answer is there? Dy by dx equal to derivative of cos of x, that is minus sin of x on divided by, so write down completely, again one more term e raised to root of cos x, and at the denominator 2 into under root of cos of x. So now this is the final solution of the given example. So take the screenshot and write down the given example. Make the practice at home very simple. First we write down the derivative of e raised to x similar. So what is the derivative of e raised to x? As it is. Then again taking the derivative of that function root cos x. So first is root. What is the derivative of root? That is 1 by 2 root. So 1 upon 2 root that function, and what is again now it's cos. So what is the derivative of cos? That is minus sin x. So in such way that we complete the given example. So now we go for the next example. Let's make the more practice. So the next example is again very simple. Y is the function of x, and now here the function is cos, and cos again into the cos there is x into e raised to x. So product is there. So by using the multiplication property of derivative, we calculate the question. So first step is very simple, differentiating y with respect to x. We get, so apply dy by dx on both sides. So when we apply the dy by dx on both sides, so our clearly observation is, so now here first we have to, what is the first function? That is cos, and what's the derivative of cos? That is minus sine of x into e raised to x. But after that our observation, the angle of sine, that is x into e raised to x. So therefore we taking the derivative of x into e raised to x, and now we clearly seen that x into e raised to x both are in the product. So therefore by using the multiplication property of derivative, so by using the multiplication property of derivative, we can solve the example. And what is the property of derivative? Dy by dx equal to u into dv by dx plus v into du by dx. So according to that formula we calculate. So let's we finish the example. So that is minus sine of x into e raised to x, and then taking the derivative of, so x into d by dx of e raised to x using this formula, u into du by dx, u into du by dx plus v as it is. So now here this is our u and this is our v. So then d by dx of that is x. So complete the question. Minus sine of x into e raised to x, x as it is. So derivative of e raised to x, that is e raised to x, and derivative of x according to which formula? X raised to n, that is n into x raised to n minus 1. So remember that now here the n is 1, so therefore 1 into x raised to 1 minus 1. So 1 into x raised to 0, anything raised to 0, that is 1, 1 into 1, that is 1. So according to that we get the final answer is, that is 1. So therefore we take the derivative of x is 1, bracket complete, taking e raised to x common, so it becomes e raised to x sine of x into e raised to x into the bracket, what is remaining? Only x plus 1. So this is the final question, final solution of the given example. Very easy, many times they ask into the examination. So make sure that make the notes of the given example. So very easy by using the multiplication property of derivative, and now it's very easy to remember dy by dx u into du by dx plus v into du by dx. So next we go for the next example. So again it's very easy to solving. What is given here? Y is the function of the x, and now here the product of the two x function, and we have to calculate the derivative, that is dy by dx. So let's we start. Very simple question. So first step is very easy, you know that everyone, differentiating y with respect to x we get. So apply the dy by dx on both sides. So when we apply the dy by dx on both sides, we clearly observe that now here the two functions are in a multiplication. So already in previous question we write down the formula. So what is the formula of multiplication property of derivative? Very simple, dy by dx equal to u into dv by dx plus v into du by dx. According to that we calculate the example. Now here this is our u, e raised to tan inverse x u, and 1 plus x square, that is v. So let's we start and finish the example. So first e raised to tan inverse of x as it is, then take the derivative of 1 plus x square plus 1 plus x square as it is, and then take the derivative of e raised to tan inverse of x, e raised to tan inverse of x. So let's we start. So very simple, e raised to tan inverse of x, what is the derivative of 1? That is 0, and x square derivative, that is 2x. According to which formula? So x raised to n equal to what? N into x raised to n minus 1, and then x square equal to what? 2 into x raised to 2 minus 1, so it becomes 2 into x raised to 1, so that is 2x. So therefore we write down 2x, then plus 1 plus x square as it is, e raised to x derivative, that is e raised to tan inverse of x, and most importantly, what is the derivative of tan inverse of x again? So we know that the derivative of tan inverse of x, that is, so remember the formula of 1 upon 1 plus x square. Now here we clearly observe that 1 plus x square, 1 plus x square get cancelled, and taking the common e raised to tan inverse x. So what we get the final answer? So that is e raised to tan inverse of x taking common. So now here remaining term only 2x, and now here remaining term only 1. So bracket complete. Then dy by dx, and final make the box. So it's very easy to remember. So here the product is there, so therefore by using the multiplication property of derivative we calculate the example. So therefore remember that in the second lecture we completely solve the question basis on the multiplication property of derivative. So once you go through that lecture, so you can understood how we calculate such examples whenever there is a product of two functions are there. So very easy to remember and very easy to calculate once you remember all the formulas. So let's we go for the last question of the given session, given lecture. So let's we complete the question. So now here again y is given is the function of sine, and the angle of sine is that is the quadratic equation. So function is present. So whenever function and function is present, so definitely using by using the composite function or the chain rule. So by using the composite function chain rule, we calculate the derivative of the given function y with respect to x we get. So that is again dy by dx on both sides, apply dy by dx. So differentiating with respect to x, so that is sine of ax square plus bx plus c. So then what is the derivative? Dy by dx equal to, so that is remember the derivative of sine, so it becomes cos ax square plus bx plus c, and then derivative of that quadratic equation. So write down the quadratic equation. So then dy by dx equal to, what is the derivative of quadratic equations? Very simple, x raised to n formula using. So what is the derivative of x raised to n into x raised to n minus 1, according to that x square derivative, that is 2x, and then x derivative, that is 1, but c is the complete constant, no function is there, so having derivative is 0, complete constant, no function is there, and derivative of constant, that is 0, remember. So let's we get the final answer is there. So that is 2 times ax multiplication plus b bracket complete into cos of, that is ax square plus bx plus c. So in such way that we complete the questions, make the screenshot of the given example. So in such way that we complete the some questions basis on the composite functions or the chain rule. So this is the very easy. So go through the one by one lectures. First lecture is very basic regarding the formulas of differentiation, along with the some questions of addition and subtraction is there. After that we go for the multiplication property of derivative. We solve the so many questions, so you can practice and understood whenever there is a two functions are there, how we solve that derivative of the two functions when they are in product. And after that we go for the division rule. So whenever two functions are in division, how to calculate their derivative. And last one, next in this lectures we complete the question the basis on the chain rule and function rule. Whenever there is a chain rule and composite, so that is whenever there is a function into function, function in function, the function is present, then we calculate in such way, very easy. And most importantly, I would like to request, please comment, or most importantly like and subscribe the channel, most importantly. Thank you very much.